Hello and welcome to my top-down shooter series in GameMaker. This is a 13-part series that shows you exactly how to make the game that you see on screen right now. It's a very beginner-friendly series, so pretty much any experience level is welcome here. And I have another series on this channel called How to Make an RPG, which is even more beginner-friendly, so you can start there too. We cover a lot of really cool stuff in this series, and we go pretty in-depth with a lot of things, so this series will really help your game dev skills. And if you're watching it as it's coming out, then there's going to be 2 episodes every week, most likely Mondays and Thursdays, or you can go to my Patreon where I have tiers where you can watch every single video right now. All 13 videos, including another bonus video. Not only that, but I also have a tier where you can get the project file download. So if you need to follow really closely and you need to actually see the code with you, you can just download the whole game or the assets to it if you want to separately. So yeah, please check out my Patreon. It is a massive help to me. And on top of that, I'm working on 2 games of my own, a turn-based RPG and an action game. And that action game is going to come out very soon. In fact, it may even be out right now, depending on when you're watching this. So checking out those games, following my YouTube channel, checking out my Patreon, all super helpful to me if this series is helpful to you. So yeah, anyways, this first episode, we're going to be focusing on getting some player movement and player collisions working. If you have watched my RPG series, this is going to be a little bit different than that, so don't skip this one. But yeah, anyways, let's get started. Good luck! Okay, so here I am in my new GameMaker project. As you may or may not know, this is how the projects normally look like whenever you open them at default. On the right here is your asset browser, or your asset tree. They fill in a bunch of folders for you to put future stuff in, and they give you a default room. So before we do anything else, I'm actually just going to get rid of all of these extra folders that don't have anything in them. That way I can just avoid a little bit of visual noise, and I can sort of categorize things the way that I see fit, and you can do the same. Okay, so to do that, you just have to right-click on a folder, and then you can go down to delete, and just delete it. Then hit OK, and I'm just going to get rid of all these extra ones like I said. Okay, so the first thing that we're going to do is we're going to make a character that can move around and collide with walls and all that stuff, right? First basic thing you're normally going to do for any kind of action game. Now, if you watched my RPG series, you kind of already know how to do this. We've done it a certain way together, but this way is going to be a little bit more clever, a little bit more interesting, and the reason we're going to do that, I'll explain as we're going. So first, let's get a little visual representation for our character, and we can just create a new sprite. So if we right click, we can go to create, and then down to sprite. I'm gonna name this S player, and then we can click down here on this first little frame that we have, and double click, and open up our image editor. So let's just make something really simple. Let's just make a little square. I'm gonna be using the little blue character that I use for pretty much everything. So just for default, I'm gonna start us off with a blue square. Now you'll see these grid lines here, and this is a 16 by 16 grid, so 16 pixels by 16 pixels. You can go over to this tiny little drop-down menu, and you can change it. I think the default is 16. The default might be 32, but if you want, you can change it to whatever you need. But let's go ahead and make a 16 by 16 size player, just so we're working with the same thing here. So I set the grid to that, folded one of these blocks. So now I'm going to go up to image, and we can use the auto trim all frames, which will get rid of all the negative space. And cool, we have a sprite for our player. So we can exit out of this, and we can now see it in our sprite asset. And if you want, you can just go ahead and change the origin point to the center of the square. And the origin point is just going to be the single point in the room that the player is drawn at specifically. I like to kind of think of it as like the grounding point of the player, or like some kind of anchor. And with something like a square, the center is totally fine for that. I'll show you how I do it with more complex sprites where there's an actual character there in a minute, but for now, this is going to be totally fine. And the last thing we want to do is go to our collision mask tab here, and you're not really going to have to do anything. You're just going to see that it's just going to darken the image. That means that the box is all the way around this box. The collision mask will be used in the future with some of the built-in functions with GameMaker to basically check for collisions. And you can use it to check a bunch of different stuff and get different variables and all that, but mostly what we can use it for is checking a collision with, say, a wall object that we make or something like that. So, just showing you that this is where we're going to edit it eventually whenever we have more complex sprites, and that's what it's for. So we are done with this sprite, and now we can actually create an object for our player. So once again, I'm going to right-click, go to Create, go down to Object, and I'm going to name this O Player for Object Player. We can open up this little sprite tab and pick a sprite from all of our choices that we have. Click on that, and now we have it paired up with our player object. So whenever we put it in a room, we'll actually be able to see it. So let's actually just do that really quick. So that way we can also mess around with our default room that we were given. So I'm going to open up that room folder, and then I'm going to double click this room here to open up my room. Now I've actually changed my settings in GameMaker, so my defaults are probably going to be a little bit different than yours. So it might not be the same size and the grid might not be the same, but just know that this is where we're going to be putting objects and stuff like that. So for example, I can highlight my O player, which is an object, and then we can place it on a layer in our room. On the left here, we have the layers. I've gone over a lot of this stuff before, especially my RPG video. So if you really need a rundown, just check over there, but know that objects go on instance layers. So you can see at the bottom here, right around here, it says left mouse button plus Alt to paint with selected object resource. So if you just hold the Alt key, you can see now I can place my player anywhere. Now you can see it's snapping to this grid that's here. I haven't placed it down yet, I'm just holding Alt and it's just showing me where it would go. So if I don't want it to snap to a grid, I can just turn it off by pressing the little grid button, and now I can move it around anywhere in the room. Or if I did want it to snap around, but maybe to nicer positions, you see the grid is twice as big as my player object. My player is 16 by 16, so we can change our grid, which is currently at 32 pixels by 32 per each square. I can go to this little drop-down menu, and just like we did in the sprite editor, you can change this. I believe the default is 32, and I pretty much always change it to 16 by 16. So now my player is snapping to a 16 by 16 grid. This is going to be very useful whenever we start putting in things like walls and stuff like that for our player to run into. And one last thing to note that you might have saw whenever we did the drop-down menu is there is actually a box that lets you decide whether or not you want the grid to actually snap, which means if I were to uncheck that, then I can move it freely while the grid is still here. That could be useful for a lot of things. Sometimes you might not want to use it. Generally, if I want to snap to stuff, I keep the grid on, and if I don't, then I don't. It's not a big deal. But just know that if you have your grid on and it's not snapping, then this might be unchecked, and you might want to check it if you want to use the snapping feature. So anyways, holding Alt, we can place items down. So now if I just actually left click, I can actually place an item here. And now I can click it and drag it and do whatever I want. So I've placed an object on my instance layer, and it's called instances because this is an instance of this object. Because you could have tons of different types of the same object, like again, say walls. You probably wouldn't want multiple player objects in a room, but if you see I put a few more down, you can see here on my instance layer here, if I click on this layer, it shows me all the objects on it. You can see they each have this different ID right here. And so these are 4 different instances of the player object. And so that's why it's called instance layers. You can click on an object and delete it if you need to, or you can also hold the shift key and click and drag to select multiple things and move them around, or delete them if you need to. Each different type of layer works a little bit differently, but for now, let's just talk about the instance layer. So good. Like I said, the size of your room might look very different than mine. It might be bigger, it might be a similar size, but I'm gonna show you what I've set it up to, because I've set it to match the camera that we're gonna use. So if you go to the bottom left thing here in our room properties, it might be minimized like this, so you can just click it and open up. Just click the little arrow, and you see we get some settings. You get the width and the height of the room. Again, not sure what yours might be set to, since the defaults are probably different, but I've set mine to 640 wide and 360 tall. And just for the sake of following through, if you're more of a beginner or you've only done a couple tutorials before, then I would say follow me as closely as you can. That way it can avoid a lot of confusion you might have, and once you're done going through the tutorial, if you want to apply this back to a different game or do different stuff, then you can go back with all the knowledge you have, and that'll probably just be a much more smooth experience for you. So anyways, I've set this to 640 by 360 because those numbers divide evenly into a 16 by 9 aspect ratio, and specifically they fit into the 720p resolution, the 1080p resolution, and the 4K resolution. They fit in evenly, so that way whenever your game scales up, you're not going to get any weird stretched pixels or half pixels or something like that. So I've set my room to be this. The room doesn't determine, the size of the camera in your game. It doesn't determine how many pixels is seen vertically and horizontally on like a game window. That comes down here in viewports and cameras. I'm making it the same size just so it's easier to see, and because in our first room we're not going to do anything fancy, we're not going to have the camera following the player yet. Now we're just enabling the game to actually display something for us. So open up this little tab called Viewports and Cameras. First we want to enable the viewports, so we want the game to actually be able to use them and display things. And then we're just going to use the very first one, which is Viewport 0, and we're not going to need to use any other ones. So I've opened up that little tab. First of all, once again, I want to check this to be visible. And you see it popped up here, and like I said, my default settings are probably going to be different than yours, but you can see how much bigger it is than the actual room itself. So let's get your screen and my screen looking the same. Let's go ahead and change the camera properties. The width, we want to match the 640, and the height, we want that to be the 360. You can see it should perfectly wrap our room around in a little binding here. And then directly under camera properties, we have viewport properties, which this is the window for all intents and purposes. Okay, so assuming you're using a 1080p screen, we can probably have our viewport double the size of our camera. So this is just how big it's going to be blown up. You see right here in my room editor, I've just hit the reset zoom button. It's a little magnifying glass with an equal sign. So that's now made this room pixel perfect. So on a 1080p monitor, if you click this, you'll see that 640 by 360 pixels only takes up this much of the screen. So that'd be a pretty small window for a game to be playing at. So I'm just gonna do it, I'm gonna double it. And you wanna make sure you multiply this by whole numbers. And you don't want your viewport to be smaller than your camera size, really. So I'm just gonna do double, which happens to be 720p, the resolution. So double 640 is going to be 1280, and double 360 is going to be 720. So if you're using a laptop or something that is at 720p resolution, the window is probably going to take up your entire screen. So you might want to just make it 640 by 360 because that would be about half of your screen size. So anyways, now that we've enabled the viewports, made them visible, set them to the room size, and set our viewport properties, we can just run the game and make sure everything's just going. So hit run. And there we go. Like I said, can't do anything yet, but we can see in our room, the window is the room, our player's over there, but you can't do anything. Great. And if you want to, you can mess around with your viewport properties here. Just remember, it needs to be an actual multiple of 640. Anyways, you get the idea. It's time to move on, and for me to not spend 600 years on this. So now that we have the game all set up to where it can run, all that stuff, we need to actually get our player to be able to move around. Like I said, if you watch the RPG series, we're going to do this a little bit differently than we did there. We're going to do it a little bit more intelligently and in a way that makes more sense for an action game, and in a way that also kind of gives us room to implement something like a controller, which I think for top-down shooters like this, twin-stick shooters are, I think, very fun to play with controllers. I tend to prefer that. So I'm going to show you how to do both. But we are just going to start with keyboard and mouse for obvious reasons. So the first thing we want to do is add an event, and we want to add our create event. The create event runs whenever the object is created as an instance in a room. So it's only run the first time it's created. And this is where you want to set up things like specific variables that you want to use. So let's set up our variables that we're going to be using for our movement. And I'm going to go ahead and comment it out. To make a comment, you just hit 2 forward slashes, and then anything I type after here is not code, it's just a comment for myself. So I can type out those two, and I can just say variables for movement, and then set those up right under here. So for calculating movement, we're going to want 2 major things. We're going to want the direction that we should move. So we're going to make one called move dir, like that. And just at default, we can just set it to 0. And then we also want a move speed, like this. And I'm going to set this as 2 for a default. So this variable is going to be a 360-degree direction for our player to be moving, and this is just going to be the speed in pixels. So if we're moving, we would be moving 2 pixels every single frame of the game. I believe the default for GameMaker is 60 frames per second. I'm using 60 frames per second. We should be all good. So anyways, for this camera size, I figured this was an appropriate speed. You can alter it whenever you want once we're done, but let's just keep it at 2 for now. And so we're going to be using those 2 variables to basically determine how fast we should be moving left and right and up and down. And so we're going to make 2 more variables called x speed for moving left and right, and y speed for moving up and down. So let's get all that started in a step event. So we add another event and go to a step event. This event runs every single frame of the game. This is where anytime you need an object to actually accomplish something or change variables or do things, and it needs to be done every single step of the game, then this is where you do it. So in our step event, we're going to want to actually move the player around, and to determine things like our direction and the final speed at which we should be moving, which for us basically means if we shouldn't be moving, our speed should actually be 0. If we should be moving, it should be our movement speed, which is 2, right? So we need to do a bunch of those things, and the way we determine whether or not we need to do these things or what direction we need to be moving in, whatever, we need to get some inputs first. We need to actually read inputs from the keyboard, and since our whole step event is going to be kind of based on reading those inputs, let's do that at the very top and very first. So let's say get inputs. So for movement, all we're going to need is simple directions, 4 directions, up, left, down, and right, whenever we're talking about keyboard controls. So let's store the inputs for our buttons in some variables, kind of like how we did in the create event. So first let's do I'm going to call this right key like this. And I'm going to set this equal to a function called keyboard check. And I'm going to close the parentheses since that's how functions work. This yellow thing is a function. I've gone over them plenty of times before. So again, if you're super beginner, my RPG series might be a slightly better place to get started, especially if you don't know what functions are. So if you're a super beginner, like I said, my RPG series goes into way more detail about all this stuff and helps you get a better understanding of really what they all are. So I'm just going to be going a little bit more quickly through this stuff, but I'm still going to cover it. So again, just know if I seem to be going too fast or at some point I kind of lose you, that would be a good series to go back to and just watch through. But anyways, a function is basically, they highlight yellow like this, and they take inputs that are called arguments. You see it down here. It's asking for a key to check for. And basically it's just checking whether or not that key is being held down. So for simplicity's sake, I'm going to use a built-in constant from GameMaker called vk_right. And basically, this is just the value to check for whether or not the right key is being pressed. And if it is, keyboard check will return 1 because it's true. So right key will be 1. And if it's not true, then right key will be 0. And as I'm sure you can guess, there is a vk_left, up, and down. And you could use that for left key, down key, up key, whatever. Or you could also use WASD, which is a format that I think a lot of people prefer. And so real quick, I'll show you how to do that. So I'm going to get rid of VK right. And to input an actual letter on the keyboard, you do this. You use a little function called ORD, and that's a function on its own, so it has its own parentheses. And then you put what key you want inside quotation marks like this. So for WASD, the right key would be D, so I'll put capital D in quotation marks like this. And now it works the same as saying VK right would be setting the right key to true or false. So since I'm assuming a lot of people want to do that, I'm just going to finish filling this out with WASD. So I've done it again. I've made left key, and then I've done keyboard check, and I'm looking for another letter, and for left it would be A. And you should be able to fill out up and down on your own. Okay, so now we're reading inputs for right, left, up, and down. Make sure all these are correct. And another thing that you need to check right now is that you are using the function called keyboard check. I know that sounds kind of dumb, since that's what we just did. However, if I put another underscore here and I start typing out more in the function, you see that there are other functions here. So there's keyboard check direct, keyboard check pressed, keyboard check release. These all do different things. For example, if we were to use keyboard check pressed, this is checking a single frame for whether or not the right key has been pressed. Not whether or not it's being held, but whether or not it has been pressed. Which means if I was using this function instead, on the frame that I hit the D key and I held it down, this function would only respond as true for a single frame, and then it wouldn't be true again until I released the D key and then pressed it again, and then it would still only be true for a single frame. So this is good for things like whenever we're gonna have like a pause button or like a shoot button or something like that. You don't wanna check whether or not something's being held, you just wanna check whether it's pressed. But for movement, you wanna check whether or not something's being held. You need that constant information from that key. So now that we have our inputs ready, I'm gonna come down here and I can say player movement. So here's where we start getting fancy. I know we're pretty much right at the beginning still, but we're gonna get fancy and we're gonna stay a little fancy for this entire series, okay? So last warning to go back if you need to watch the RPG series or something like that, and you think that would be beneficial to you, because now we're gonna start doing some kind of cool stuff. And if I were to break everything down as sort of minutely as I did in my RPG series, then this would last for a very, very long time. So anyways, first thing we wanna do is we want to get the direction that the player is moving in. And we can do that using these inputs. So I've tabbed this out and I'm just going to put like a little sub section here, and I'm going to say get the direction. And we need to find two values that we're going to store in local variables. So I'm going to say var to create a local variable, and I'm going to call it underscore horiz key, like this, for horizontal key. When you create a local variable like this, it only works in the event that it was declared in. So I can't reference this in a create event, or if I made a draw event, I couldn't reference it anywhere else. I can only reference it in the step event under where I set it. So we're not going to need these values pretty much anywhere else except right here, so that's why I'm doing this. They highlight the light yellow, and having the underscore there just makes sure that I'll never accidentally name it the same name as like an actual variable that I have. Anyways, this is going to be the sum of our right key and our left key. So we're going to do it like this. We're going to say right key minus our left key. Or I suppose I should have said difference, not the sum. So like I said, these functions return ones or zeros. So if our right key is being pressed by itself, we're going to get 1 minus 0. So the horizontal key is 1, which is positive, so it's going to the right. And then if you get 0 minus 1, it's going to be negative 1, so it's going to the left. And if they're both being pressed, then they're both pulling in the same direction, which means 0, so no movement. So you can see how this is going to help us determine the direction the player should be moving in. And so now we need to do one for the vertical keys as well. So I'm going to say underscore vert key equals. If you're unfamiliar, you might need to do the opposite of what you think you need to do. So we actually need to do down key minus our up key. Because basically in GameMaker, the y-axis, as it goes down on your screen, the numbers increase. That's just the way it works in GameMaker. If I open up my room really quick, I can show you. You see down here, with these changing numbers right now, this is the coordinates that my mouse is at right now. So if I'm at the top left right here with my mouse of my room, you see that it's coordinate 0, 0. And watch as I go down, the y value on the right there is increasing, and as I go up, it's decreasing. It's just the way it works in GameMaker. So to get our vertical key direction, we need to start with the down key and subtract the up key from it, because that way if we're pressing down, we get 1 minus 0 equals 1, which would be the positive direction of going down, and up key being pressed by itself would be negative 1, which would be going up. So now we have these sum parts of our horizontal and vertical keys. How are we going to actually use that to find like a 360-degree direction? Well, easy. Let me show you. We're going to store this in our move direction variable that we set in the create event. So we're going to say move direction equals, and we're going to set it to the function point direction. And if I click on this, you'll see down here, it takes in a bunch of different arguments. It takes in an X, a Y, and then a second X and a second Y. So 2 coordinates. And then what this function does is very simple. It calculates the direction that the second point is based on the first point. Pretty easy. So if the second point was directly to the right of the first point, it would just be a straight horizontal line. And going left to right, that would be 0 degrees. Because that's generally how 360-degree circles work on a graph. Would be to the right is 0, and then as you go counterclockwise, the degrees increase. So if you had the second point be directly above the first point, that would be a straight upwards vertical line. That would be 90 degrees. Straight to the left would be 180, straight down would be 270, and then back to straight right would be 0 or 360. So very easy. It's just calculating the relative direction that the second point is from the first point. And we are already getting right here, basically an X coordinate that is either returning -1, 0, or 1, and a Y coordinate that is getting -1, 0, or 1. Right? So if we were to start our first point at 0, 0, so 0x and 0y, and then we were to input these directional keys like this, so horizontal first and then our vertical, now we're basically just getting a straight up graph like what I was talking about, with the first point being in the origin and then the second point being the sum of our keys. I'll put a little, hopefully I have a little graphic up there for you to kind of illustrate what it's doing. But hopefully that should make sense to you. So now, based on the directions that we've been pressing on our keyboard, we know the direction that we want the player to move in. And now we just need to figure out our speed, which we know we want our speed to be 2. We already set it in our variable up here, but we only want it to actually be 2, and we only want to move while we're actually pressing the buttons, right? So let's go down here and let's say get the X and Y speeds. So now I'm going to do a couple more local variables. The first one I'm going to do, I'm actually just going to call var underscore speed, since this will be the final speed that we're actually getting. At default, I'm going to be setting it to 0. We only want to set it to our movement speed once we know that we're actually inputting, right? That we're actually pressing buttons to move. So start that at 0. Then I'm going to make a second local variable, and I'm going to call this maybe something like underscore input level, like that. So the amount of input that we're getting. In our case right now, it's basically just going to be 0 or 1. So how are we going to determine this input level, the amount of input that we're doing? Well, we're actually going to use the counterpart function to point direction. We're going to use a function called point distance. It's extremely similar, and it does exactly what you think it does. it also takes two coordinates, so an x and y, and then a second x and y, and then it basically just figures out on a graph what would the distance between those 2 points be. So we're going to input the same exact thing actually. So we're going to do 0, 0, and then we're going to do the horizontal key and the vertical key, just like this. So this basically means if we're not pressing any of these 4 buttons, then both horizontal key and vertical key are going to be equal to 0. And so the difference between coordinate 0, 0 and coordinate 0, 0 is 0. Big shocker there. So this is how we're getting our input level. Say we're pressing the right key, then horizontal key is 1, vertical key is 0. How far is the coordinate 0, 0 from the coordinate 1, 0? Well, it's just one single unit away, right? And that works from any direction. You're not going to get negative distance because negative distance doesn't really exist, right? So it doesn't matter which direction you have to go. Coordinate -1, 0 is still only one space away from coordinate 0, 0. It doesn't matter that either of the numbers are negative. It's just returning a real physical distance between the two. The order of these two coordinates, unlike this function, doesn't matter at all. This one needs a base coordinate and then a secondary one to get the correct direction, but this one is just getting the difference between the two. So great, we have our input level. There's actually a little issue with this code, a little tiny one, and if you're sort of visualizing the graph in your head, you probably know what this issue might be. But I would rather demonstrate all this working first, and then we can fix this little issue. Plus, it'll be easier to show you what the issue is before we actually go about fixing it. Okay, so before we do any of that, let's just continue on, because we can't move on until we update our speed variable, right? Because we want it to match our movement speed and the input level at the same time. So we could do that like this. So we'll say speed equals, first we're going to say it equals our move speed, but then we're going to multiply that times our input level. So like I said, this input level is generally going to be returning either 0 or 1. So essentially, just if we're not moving, we're going to get our movement speed times 0, which is 0. And if we are moving, we're going to get our movement speed times 1, which is our movement speed. So great. Now we have the direction that we want to move in, and we have the final speed that our player should be moving at. So now we're going to introduce one more function like this. First, let's set our x speed. So we'll say our x speed equals, then we're going to use a function called length dir underscore x. And this takes in 2 arguments. It takes in a length, obviously, and a direction. Our length is just going to be our speed, and our direction is going to be our move dir, right? So what this function's doing, I should have a little graphic up for you right now. This function is just returning the x value of a coordinate that is a certain length or distance away from the point 0, 0 and a certain direction away from the point 0, 0. So if you pair that with the other function, which is length dir y, which does the exact same thing except it returns the y coordinate of that second point from the origin, then you can see how it's really useful. It means that you can input any 360 degrees that you want to right here, and then you can use these functions, in our case, for moving a player. We can see how fast we actually want the player's x speed to be if we want to move towards that coordinate. So hopefully that didn't really get too word salady for you. So let's just do the y speed really quick and do length dir underscore y, and it's going to take the same exact arguments, so speed and move dir. So for example, let's just say that at any point our speed is going to be our move speed, right? So let's say this number is always 2. If our direction is 90 degrees, so straight up, which is what we got over here, and that's based on what buttons we're pressing, the coordinate that is straight up from the origin and 2 spaces away would be the coordinate 0 and -2, where x is 0 and y is -2, right? Because remember, if we go up, the coordinates are negative. So that would mean that if we were pressing upwards, our direction would be returning 90 degrees, but our speed is 2, then that's returning our x speed to be 0, which is good because we don't want to move left or right, we're only pressing the up button, and our y speed is -2, which would make the player move upwards. So hopefully all that makes sense, and now we just need to move the player, right? And to do that, we just have to add our x speed to our x, and our y speed to our, oh my gosh, to our y. And this will always work out because if we're not pressing any buttons, it'll just be adding 0, which won't be changing anything. And if we are pressing buttons, then we're kind of figuring out everywhere it needs to go. So you can see that using this length direction thing, the theory here that we have running is that no matter what 360 degree direction that we're pressing or inputting, we're still moving the correct distance and speed in that direction. And you can really imagine how this would be helpful for, say, an analog stick on a controller, which can, in fact, go all 360 degrees, but it's also good for keyboard and mouse. Now, anyways, look this over, make sure everything's all right, and now we're pretty much ready to actually test it. So if you didn't do what I did already, go ahead and open up your room and drop your player in the room, just anywhere, doesn't matter. And now we can run the game and check it, and let's make sure that we did everything right. So first things first, the player isn't moving, which is good because I'm not pressing any buttons. And let's see if I press some buttons. Down, up, left, and right work. And we can just move all around. I'm using the WASD controls because that's what I used. Maybe you use the arrow keys. Just make sure you're pressing the right buttons, all right? But yeah, look at that. So we got a player moving around, which is great. However, I just went on a big spiel that included a lot of functions and stuff and graphs and whatever, explaining how this is supposed to make sure all of our movement is completely even at all directions. And maybe it's kind of hard to tell, especially since a lot of games function this way already, but that's actually not happening right now. If you see me moving left and I start moving up and down, my speed going left actually hasn't changed at all. So I'm still moving up and down, but instead of actually zigzagging, like how something realistically would, I just maintain my horizontal speed, which basically means that if you're going at a diagonal, you're actually going way faster than if you're going right, left, up, or down. So like you can see it too, like watching me just go this way. Then look how much faster it looks when I'm moving only at diagonals. It seems like I'm going way faster, and that's because I literally am. So what happened there? What happened in our player object that messed all this up? Well, you heard me mention it earlier. I said that there was an issue right around here, right? And that we would come back to it. It's because I wanted to show that off first. But now let's think about this line. Maybe you already know what's up, but if not, let's go through it just really quickly. So, point distance, as I said, just returns the real distance between these 2 points that we input. Horizontal key and vertical key are both either returning, respectively, -1, 0, or 1. Which makes sense for going up, left, and down. If you're just going at a straight line up, left, or down, then any of those points would just return the number 1. However, think about our diagonals, where what is the distance between 0, 0 on a graph and 1, 1 on a graph? It's not actually one space. It's a little bit longer than that. I think it's like 1.4, around 1.4 or around 1.5, actually. And the same with any of the other diagonal directions. So what's actually happening here is whenever we press diagonals, our input level is returning, like I said, I think it's 1.4 something like that. And it's multiplying our move speed times that. And basically what that's doing is it's basically maintaining our vertical and horizontal speeds and compensating for the different direction that we're going in. So it's basically just doing this really kind of binary thing where if I'm pressing down, I'm going down 2 pixels at a time, and if I'm pressing right, I'm going right 2 pixels at a time, no matter what other button is being pressed, unless another button is canceling one of those out. Which that's exactly how the RPG series movement worked, because that was just a little bit more simple game. But we did this in a much more complex way if you did that series. So as you can imagine, it's pretty important that we actually fix this to make all this extra work worth it, right? So I'm going to do something very simple, and I'm going to clamp this variable, the input level, to make sure that it can never be above 1. So to do that, let's say our input level, and now we're going to set it to clamp, which clamping something, we can input a value. So the value that we're going to input to it is just going to be the input level itself already. And then we can give it a minimum and a maximum value. You can see down here. And for minimum, we don't ever want it to be below 0 because there would be no reason for that. And we don't ever want it to be above 1. So now our input level is kind of almost returning like an analog input. It's returning from nothing to all the way. And it doesn't matter what buttons we're pressing or anything like that. It will always return between 0 and 1. Which means now when we're getting our speed, the length is never going above our movement speed like it was before. And whenever we use our length direction functions, we're basically always going to be returning a perfect circle around the center of our grid. So let's try that out real quick, and you'll see what I mean. Okay, so now if you see when I go diagonals, I'm going the same speed as whenever I was going left and right, which makes sense, right? If I'm just holding right, I should be able to get to the edge of the screen faster than if I was zigzagging while doing it. And so now the speed is working completely accurately, and it would be working for all 360 degrees, not just these 4 buttons. And so that's the very basic movement. As I mentioned a couple times, one of the main reasons that we do it this way is because this is very, very good for controllers and analog sticks, for one. So whenever we want to add those in, whenever we will later, I can do it super, super quickly, and it'll work totally fine, and it'll slot in super easily. But not only that, the game that we're making right now is like a top-down shooter. This is like a real-time action game. I'm not generally one to say, you know, for all action games, this rule should be in place for every single game. So I'm not saying this is a definitive statement, but just in general, I feel that in something like a real-time action-oriented game, having a consistent movement for the player is going to be very important for the player making decisions for dodging and things like that, for positioning themselves while they're shooting, all that stuff. It's kind of a little bit easier for the human brain to settle in to understanding, okay, if I'm going downwards and left, I should be moving at the exact same speed as if I was just moving to the right. You know, it means that the players don't have to factor in this weird difference that the diagonals make. Might be sounding like I'm making a little bit bigger deal out of it than I should. That's probably not wrong. However, it's just something good to think about whenever you're designing video games, you know? There are plenty of great video games out there that don't do what I just said. However, it makes sense for this project, I think. And it's good to learn a lot of those functions. They can be extremely useful in a bunch of different scenarios. So yeah, that's why we're doing that. Okay, so the last basic thing that we have to cover is the collisions. Collisions are usually a super simple process, and it's pretty simple here too. However, we have one thing that we need to kind of consider. Recall in the demo that I did of this, that you saw at the very beginning of the series, there are actually two kinds of different walls going on. You might not have realized it, but you'll know what I mean whenever I talk about it. There are the actual walls in the game, like the elevated ground, and there's the stuff like the little stone mausoleums and pots and crates and stuff, trees, whatever. Those are obviously walls, but as far as the player and the enemies were concerned, they could also run into things like the water, or like holes in the ground, right? Like pits. We don't want our players and enemies to walk directly over pits and water. However, things like bullets and projectiles, we don't want them to collide with these invisible walls that go over like the boundaries like that. And same for any kind of enemy that maybe is like a flying type of enemy. Maybe the player gets a power up where they can like float for a little bit and they can kind of go over those little areas. Something like that, right? So two kinds of walls. A wall that literally everything can run into, and a wall that things like projectiles can avoid. So let's just start simple. We know we need two different kinds of walls, but we can just start with one. So let's do that first, because that's going to be really simple. Let's go back over here and make a sprite for our wall. So create sprite. I'm going to call this S wall, and I'm going to make S wall a yellow. And I'm kind of strategically doing this. So if I were you, I would do something similar. But anyways, we're going to kind of do this the same way as we did the stand-in for the player. We can also go over here to our layer and double click it and open up these little settings here, and we can change the opacity of the layer. And I'm going to set it to about halfway, so that way whenever I place my walls down, anything in the room can show up underneath it, so I can still see kind of through them. So cool. We go back up here to image again, and we're going to do the auto trim all frames to get this back down to a 16 by 16 square. Cool. We come out here. Again, our collision mask should be fine. It should just be the entire image. If this isn't matching up for whatever reason, you can go to mode and do a drop down and select manual, and then you can change the shape of the collision box on your own. But we want it to be the whole image anyways, so just make sure it matches. And the one thing different we're going to do to the player is keep the origin here at the top left. That'll make it way easier to stretch it around in the room editor. So cool, that sprite's done. Now let's make the wall object. So right click over here, create object. I'm gonna call this O wall. Good. I'm gonna select our wall sprite for it. And here's the good news. We are now done with the wall object. Any collisions that we're gonna calculate in this game, we're gonna do in the other objects. So the player is going to check for a collision with the wall and the enemies and stuff like that. The wall doesn't actually have to do literally anything. So cool. I can go ahead and close this. We can go back into our player and add in that collision code. And here's the other good news. This is going to be incredibly simple. So what we're essentially going to do, we have our X speed and our Y speed here, and we're adding it here, right? So in between these two, after we've got the speeds and before we actually add them to the player, we can use X speed and Y speed to check where we're going to be by next frame, right? So let's do this. Let's add collisions right here, and we can use this function, and we say if place meeting and highlight it, and we can see it takes 3 different arguments. It takes an X position, a Y position, and an object to check for. And what place meeting does is whenever you input X and Y positions, it checks if the player would be colliding with whatever object we input if the player was in that position. So like this. First, let's do our X because we're going to do our X and Y separately. So we could say we want to check the position we're at plus where we will be, which is the X speed. Then we can check our Y position, just where we already are, and we can check for O wall. So if I were to add my X speed to my X coordinate, would I be already running into a wall? Would I be inside of a wall? And if that is true, then we can just set our X speed back to 0. So now our player will not move into the wall. Simple, easy peasy stuff. We could also do the same thing with the Y. So we would say if place meeting, say X, and now we want to do our Y plus our Y speed, since now we're checking the Y position, obviously, checking for a wall collision again. Then we want to set our Y speed to 0. So this basically is our collisions. That's it. So let's test this out really quick. Make sure you have all this copied right. Make sure you're using X speed and X speed here, and you're using Y speed and Y speed here, and make sure that you're checking for X plus X speed and Y plus Y speed. Okay, so let's go into our room, and we're gonna go on our instance layer because our walls are objects. Highlight our wall over here, hold the Alt key, and put some walls down. And like I mentioned in the sprite editor, because our origin's at the top left, it can very nicely scale like this, so you can stretch the walls around. Do that however you want to. So let's just put some around and then test it. And there's right, there's up, there's left, and there's down. Okay, cool. We are running into everything. Nice. Okay, so one version of the wall's down. So this is going to be the type of wall that we would put over things like pits, holes, water, anything like that, right? Now we need to have a second type of wall that can do everything that this wall can do, but also has its own identity. So that way, any special flying objects like projectiles can just check for that one and ignore these yellow ones. So I'll show you how we're going to do that. So I'm going to clear my workspace really quick by closing that, reopening that. Okay, so let's make a sprite for our second type of wall. So create sprite. I'm going to call this S solid wall, because like I said, these are going to be the ones that don't go over water or over holes. They go over solid material. So I'm going to open up my frame here, and I'm going to pick a red color for this one, and that's kind of why I picked yellow for the other one, since I think red kind of gives off a vibe of more serious business, you know what I mean? So this is going to be the kind of wall that literally everything will be able to run into. Players, enemies, projectiles, whatever. So I'm going to do the same I did with the last one, put the opacity at about half. There we go. I'm going to auto trim. I'm going to check back and make sure the collision mask is the full image, just like with the yellow one. Origins at the top left. Good, good. And now I'm going to create my O solid wall. Do what I did with the last one. Select the correct sprite, so the red one. So now I have my object solid wall. It has its correct sprite. Now what you might be thinking is, okay, we have these two different wall types. What I need to do is I need to have the player checked for a collision with object wall, and I also need to have the player checked for solid wall over here. And for something like an enemy bullet or a player bullet, I only should check for solid wall. That technically would work. So if you thought of that, good thinking. That is one way to do it. However, there's two specific issues with that make it basically just suboptimal. It's not that it wouldn't work, it's just that it gives you more room for error and mistakes. First of all, for every single object that you want to collide with both the yellow walls and the red walls, you would have to do the collision check twice, which is obviously twice as expensive in terms of processing power. And if you have a bunch of enemies on screen like I did, that'll be a bunch of enemies checking for collisions twice every single frame instead of just once. So you can see how that could stack up and eventually could cause problems performance-wise with your game. So that's the first reason you don't want to do two separate collisions like that in this scenario. The second reason is that would mean that anytime you made a new object, you would kind of have to remember to make sure that you were checking for literally both of them. So it just kind of gives you a little bit more room to accidentally make some mistakes in your programming down the line. So here's how we're going to solve this issue. Let's go back into our solid wall, and what we're going to do is we're going to open this parent tab. Now the parenting system is really, really cool. It basically means we can do this. So let's click over here, open up a parent, and we want the parent of our solid wall to just be our yellow wall object. So now, anytime GameMaker looks for O wall, for example, when the player looks for a collision with O wall, all of the solid walls also inherit its properties and technically also count as O wall because it is a child of this parent object. So as far as this collision code for our player is concerned, now O wall is checking for both O wall and O solid wall because GameMaker is considering them to be the same thing in this scenario. So let's test that out really quick. Let's go into our room, and I'm going to get rid of this yellow wall, and I'm going to add in some of the solid walls, so the red ones. So maybe one there, and we'll say maybe this one is going to be a red wall as well. So let's test that real quick, and look at that. We are colliding with the red walls, and the yellow walls. Pretty cool. But let me show you how this works the opposite way. Because in that scenario, it kind of just seems like I've made these walls be the same thing. So why are they even two separate objects? Well, like I said, if you're checking for an object like this, it also checks for all of its children object, which includes object solid wall. However, parents do not inherit traits from the child, right? So if we're checking for a child object, like object solid wall for both of these, now we are only checking for object solid wall in any of its children. Object wall is not a child of object solid wall. So if we run our game now, we should be running into the red ones, but we should be ignoring the yellow ones. So if you pretend for a second like the player is a bullet instead of the player object, the yellow walls would be, say, this would just be like a pit, like a drop off. The bullet should fly over the pit, but it should run into the wall, right? And yeah, so that's it. So from now on, we just need to make sure that we're checking for the right one of these two objects. The player should run into solid walls, but the player should also run into regular walls. So now that I've changed it back, I'm running into both. Perfect. So our collisions are pretty much done, and we now know how we're going to handle them for all of our other objects. Now, obviously something you may have noticed is that sometimes you can get these gaps, like you see, whether they're tiny gaps or bigger ones like this. This is because the collisions that we're using right now are not pixel precise or sub-pixel precise, and our speed is at like a 2, which is pretty big. There is a way to get rid of this little gap here. However, we're not going to cover it quite yet. That's for a couple reasons. The first and foremost is to just keep this simple right now, and the precise collisions would require us to start getting into loops, which loops are something that's a little bit nicer to deal with when you just have a little bit more experience, because if you're not doing it right, loops can freeze your game if you can't really fully logic them out. And this isn't going to be nearly as much of an obvious issue once we actually have our player sprites working, because it's not going to be as obvious because they're not just going to be a single square. So I say, let's go ahead and move on to that. Okay, thank you so much for watching part 1 of the How to Make a Top-Down Shooter series. Like I said in the intro, we have 12 more episodes to do after this, and there's also a bonus episode after that one. And not only that, but since the project is finished, as I mentioned before, it's all on my Patreon already. Pretty soon after this video goes up in the first place, so towards the second half or towards the kind of end of October 2022, I'm going to do a live stream. And basically what I'm going to do is I'm just going to take the project that we have by the end of this series, and I'm just going to add some stuff to it for fun, add some more enemies and some more bosses and levels and things like that. And I'm just going to kind of work at my own pace, not necessarily like tutorial pace or anything like that, but just show off some more of the creative stuff of it. So it should be fun. You won't need to have watched the whole series to watch the stream, because obviously it's just going to be me working around on something for fun. But after that, I'll put up the little game that I make actually for download somewhere for free, or on like the Opera GX GameMaker browser thingy, which you can just like upload games to and play off your browser, which is cool. So yeah, I'm planning on doing something like that. So it should be really fun. So if you want to catch that, then you should definitely subscribe and ring the bell. And if you don't want to miss any more of the future parts, you should subscribe and ring the bell as well, you know, all that kind of thing. And if you want to be the coolest freaking cat around, then you can follow the example of Nixionic, Red Dragon Redemption, Null, Joseph Sandlin, Midnight, Jerica Deloach, hope I got that right, and Mark, all of which are currently my star gamers on my Patreon. So thank you guys so much, and thank you so much to all my other patrons as well. Again, if you want to get your name up here, or if you want to get your name read out, or if you want to get the rest of this series early, or you want to get the project file download, or whatever other kind of stuff, Patreon updates, whatever, please go over there and check that out, because again, it's super helpful to me, and you can get some cool stuff too. So again, thank you guys so much, and also thank everyone who's just watching right now, and everyone who has subscribed and liked the video and done all that stuff. It means a great deal to me. And like I said in the beginning, I am putting out a game very soon, or it is already out depending on when you watch this, called Starcross Starcade Special. It's an action game. It's kind of a hybrid RPG / action game where there's kind of like two halves of the game where you're doing pretty different stuff. But I won't talk about it too much, but this series took a really long time to make, and so I've had to put a lot of personal projects on the back burner, and I'm finally able to get back to them like right now pretty much. So yeah, I'm hoping this does pretty well in the meantime. But anyways, you can wish list Starcross Starcade Special on Steam right now. Links are in the description. The other best ways to follow it are to follow me on Twitter and to follow me here on YouTube. So yeah, that's really all I have to say for the end of this. The intros and outros for the rest of these parts probably won't be as long, since that was pretty much everything that I need. Otherwise I'll probably just mention my Patreon and games every now and then. But other than this first part, you probably won't hear me ramble on too much about this stuff. So thanks again. Oh, and one last thing I forgot to mention. If you join the Patreon now, as long as you are active on the Patreon at the time that a video goes up, then you will show up in the credits of the video, and that goes for the $10 tier as well. As long as you're supporting at that tier at the time that I finish editing the video and go to post it, then you will get your name shouted out. So yeah, thanks again. You're the best, and see you in the next episode. Bye-bye.